Most cylindrical lithium-ion cells are made of metal, which is particularly important as the battery is pressurized. This casing will typically have a pressure-sensitive vent port, which will release extra pressure if the battery ever reaches temperatures high enough to risk explosion. If the vent is utilised, the battery will typically be useless afterwards. Therefore, it is strictly there as a safety measure. Alternatively, prismatic cells are designed thin and light. They can use either steel or aluminium casing, which makes them more stable. This enables them to be easily connected to create different voltage requirements. Whilst they can be more costly, their thinner layering and rectangular shape allows the product designer more flexibility. Both designs typically consist of 3 thin sheets pressed together: a positive electrode, a negative electrode, and a separator, which are submerged in an organic solvent that acts as the electrolyte. The separator is a very thin sheet of micro-perforated plastic, and as the name implies, it separates the positive and negative electrodes while allowing ions to pass through. The positive electrode is made of lithium ion, which is commonly mixed with another chemical compound, like cobalt oxide or phosphorus, to create a specific lithium chemistry, which, depending on the chemicals used, will provide the battery with a range of different performance and safety benefits. In most cases, the negative electrode is made of carbon. When the battery charges, ions of lithium move through the electrolyte from the positive electrode to the negative electrode and attach to the carbon. During discharge, the lithium ions move back to the lithium from the carbon. The movement of these ions occur at a high voltage, resulting in a typical cell between 3.2 to 4.6 volts. This is much higher than a typical 2-volt cell seen in lead-acid technology. Therefore, less cells are required to achieve a desired battery voltage.